In this example, we're going to compare the alcoholic drink preferences for males and females. We'll use a bootstrapping function in StatKey. Data were collected from a representative sample of World Campus Stat 200 students concerning their alcoholic drink preferences. We want to estimate the difference between the proportion of males who prefer beer and the proportion of females who prefer beer. In our sample, there were 36 males. 15 said that beer was their preferred alcoholic drink. There were 40 females. 8 said that beer was their preferred alcoholic drink. Let's go to StatKey. Here, we're going to create a bootstrap confidence interval for the difference in proportions. We're not using a built-in data set, so we can click Edit Data to enter in our summary data. Group 1 we'll call males. 15 out of 36 males in our sample said that they prefer beer. Group 2 will be the females. 8 out of 40 in our sample said that they prefer beer. When we click OK, this changes our original sample. So group 1 is our male. 15 out of 36 gives us a sample proportion of 0.417. Group 2 are the females. 8 out of 40 gives us a sample proportion of 0.200. The difference in our sample proportions, in other words, p hat 1 minus p hat 2, equals 0.217. Let's generate a few thousand bootstrap samples. Here I've generated 5,000 samples. The mean difference in the proportions is 0.216 with a standard error of 0.103. At this point, we could use the standard error method and take the mean plus or minus 2 standard errors. My preferred method is to use the percentile method. So we click to tail, and the default here is a 95% confidence interval. So the proportions that separate the middle 95% of bootstrap proportion differences are 0.0083 and 0.414. I could say that I am 95% confident that the difference in the population proportion of males and females, in other words, males minus females, is between 0.83% and 41.4%.